Okay, here we go. Unit 2, single variable linear equation. Again, my name is Glenn Dawson, and I'm your lecturer. So here are our objectives for this particular unit. Students will learn how to transpose and when to transpose. You will learn the principle of solving equations and learn how to solve equations by transposing. You'll also learn how to check the answer you get after you've solved an equation. So let's talk about transposing. So if I have, for argument's sake, P plus 2 is equal to 5. This is an equation. I'm trying to solve for P. So what I'm looking for is in the end, I'll have P is equal to something. So for right now, the left-hand side has both the variable and the constant. And I want to get that constant out of there. So I want to take it on the other side, which in this case would be the right-hand side. It's not always going to be the right-hand side, so I said the other side. So what I do is I realize I've got to get rid of this 2. And if I subtract 2 here, then 2 minus 2 would be a 0, and I'd be left with just P over here. But there's a principle that we must follow in solving equations. And that principle is what we do on one side of the equation, we must do on the other side. So if I subtracted 2 on the left-hand side, I must subtract 2 on the right-hand side. So now keep in mind over here, these would cancel. Positive 2 and a negative 2, so I'll be left with just a P is equal to 5 minus 2 is 3. And that is the correct answer. So what we do when we transpose is we kind of skip this little baby step. This is kind of a baby step, but this is the principle behind it. Let's take another look. So we had P plus 2 is equal to 5. I know what I want to do is I want to take this constant and take it over here. That is transposing. But for me to do that, I've got to take the opposite sign. Now over here, where I showed you just now, this is the principle behind it. So I'm going to subtract 2 on both sides, which is how we end up with a minus 2 on the right-hand side. But the short way to do it is just to transpose, and simple means if I'm going to take a constant from one side to the other, I've got to change its sign. All right. So now taking this over here, I'm going to have just P over here is equal to 5, which was over there. And I'm taking this 2 over here, but it was positive where it came from. So now it's going to be negative. So right here, we have transposed. At this point, we have transposed. In fact, to be more specific, we transposed a positive 2. Therefore, on the other side is going to be a negative 2. So again, we see doing that, we get P is equal to 3, which is the right answer. So let's try another one. Let's say I had 2x minus 6 is equal to 10. Again, this is a constant. This does not have x in it. This is not an x term. This won't help me to get to the point where I'm going to get x is equal to something. So I want to transpose it. So I'm going to take this and take it over here. Take it on the other side. I'm going to transpose a negative 6. When I do that, it's going to become a positive 6. So 2x will stay on this side. 10 was already there. And now I have positive 6 right here. Because it was negative where I brought it from, now it becomes positive, I have transposed. Am I finished solving the problem? No. No. Because when I'm done, I'm going to have x is equal to something. So I'm not finished solving the problem. But for this slide, all I'm doing is showing you what transposing is. Now, in terms of when to transpose, We're going to transpose when we want to get rid of something from one side of the equation or not. And our circumstance will dictate that. It may be a variable. It may be a constant. We will find out as we move on. Okay. So let's take a look at this particular problem. Okay. Now, at the end of doing this, I'm going to show you how to check your answer. All right. So for now, let's take a look at this. This right here, this -3, I want to transpose it and take it over here. And the reason I want to is because I want A on the side by itself is my variable. So when I transpose this -3, I'm going to be left with just A on the left-hand side, and 7 is already on the right-hand side. So now I'm going to have +3. Okay, so I transposed a -3. So it becomes plus on the other side. Okay, we only utilize transposing when we're adding or subtracting. So either it will become from a plus to a negative or a negative to a plus. Okay, so now A then is equal to 7 plus 3, A is equal to 10. This is the answer I've gotten. Now, how do I know it's correct? It says at the bottom here to check your answer, substitute the result, which in this case is 10, where the variable is in the original equation. So the original equation was A minus 3 is equal to 7. And observe that the mathematical statement is true. So if I plug in 10 where I see A, so if this is 10, then this becomes 10 minus 3 is equal to 7, and that is correct. 10 minus 3 is 7. 7 is equal to 7. So mathematically, this statement is true. Therefore, I got the right answer. So now you know how to check your answer. You don't want to forget that. Again, I expect you to be taking notes. Because this is a recorded video, you have the option of pausing this video to make sure you get your proper notes. Okay? All right. So let's try another one. Let's take a look at x plus 5 is equal to 11. So clearly when we're finished, we're going to have x is equal to something. Now we know that we need to take away this 5 from here because it's in the way. It's a constant. We want x variables on the side by itself. So what I'm going to do is I'm going to transpose this 5. So x stays on the left-hand side. And 11 was already there, but now this becomes minus 5. Why does it become minus? Because in its original side, where it's coming from, it was plus. So now x is equal to 11 minus 5, and 11 minus 5 happens to be 6. Now, if I want to check my answer, I plug 6 where x was in the original equation. 6 plus 5 is in fact 11. I know I have the right answer. Okay? So what we want to do is we want to get systematic. We want to take a look at the process, because if we follow the process, we're going to be just fine. We may make mental errors. For example, you might say 11 minus 5 is actually 5. We can go back and check those. We can go back and check our work. But if we follow the steps, the proper steps, we'd be just fine. All right? So what you want to do now as I work this next one is you want to pause the video and try it for yourself. And then you come back and follow my working. Okay? Okay, so I'm presuming you did that and now you're back. And this is a pretty easy one. The principle is the same. I want to take this -4 on the other side because I want P on the side by itself. P is my variable. So I'm going to transpose that. So I'm going to have P is equal to 0. That's already there, but it's going to be +4. So P then is equal to 0 plus 4, which is 4. And again, we could check that very easily by substituting 4 where P was. 4 minus 4 is in fact 0. I have the correct answer. All right. Again, you know the deal here. This is a new problem. Pause the video and give it a try. All right. So what happens here now is that this bad boy right here, this one right here, is in my way. I want to take this and take it over here. Okay. Now, there is no sign in front of the 20. But when there is no sign, it's a positive number. Okay? If it's the first number or the first term in a mathematical statement, if it doesn't have a sign, it is positive. Okay? So if it's positive on the left-hand side and I want to take it to the right, when I take it over there, 25 was already there, then this is going to be minus because it was positive over here. So x is equal to 25 minus 20, which is 5. And again, by now, before you unpause the video, you should have also checked your answer. You'll get 20 plus 5 is in fact equal to 25. Okay. All right, so here's another one. This is a little different, so you might not want to pause this one and try it, but if you're confident, go ahead. This one is different because we have two different instances of the same variable. So we have to do a double transpose in here, right? But that's okay because we learned about grouping like terms. So what I'm going to do then is I'm going to take this x on the right-hand side and I'm going to take it over there on the left-hand side. Okay, why am I going to do that? Because I want all the x's on the same side because I'm looking for x. And clearly then, this -4 that's here, I'm going to take this over on the right-hand side. So it's along with the constant. So I'm going to have just x terms on the left-hand side, and I'm going to have just constants on the right-hand side when I'm through. So let's go. So I'm doing nothing to the 2x, so I'm still left with 2x on the left-hand side. I'm still left with 2x on the left-hand side. But now I'm taking this x that's on the right-hand side over, which means it's going to change its sign. Recall I told you that if there is nothing in front of the x or the variable or the constant, sorry, that it's positive. So if it's positive on the right-hand side, when I take it over on the left-hand side, it's going to be negative. So it's going to be minus x. And then on the right-hand side, I already had 5, so let's bring on that 5. And then this -4 that's on the left-hand side is going to be transposed to the right. That -4 becomes a +4. Now keep in mind, we learned how to do 2x minus x in unit 1. Okay, 2x minus x is just 1x, which is just x. So then x then is equal to 9. Now this is a fun one for you to try, to verify. Okay, you want to plug in 9 wherever you see x. So let's try it. So on one side, I have 2x minus 4. So if I plugged in 9 here, if I plugged in 9 there, this would be 2 times 9 is 18. So it'll be 18 minus 4. This is on the left-hand side. Let me just write that here. This is the left-hand side. 18 minus 4 is 14. Now on the right-hand side, what we had, so remember there's an equal sign here. We had x plus 5. But we're going to plug in 9 wherever we see x, because 9 is what we got. So I'm going to get 9 plus 5, which is in fact 14. So 14 is equal to 14. So it's a mathematically true statement. So my answer is correct. Okay, so we don't want to get intimidated just because we see multiple existence of the same variable. And remember, we're not going to see other variables. We're going to see more than one variable in a problem because this is a single variable chapter. Okay. So moving on, here's one. You could pause the video and give it a try. You should have that problem that we just did in your notes. And we're going to work it the same way, pretty much the same way. Okay. All right. So what we want to do here is we want to take the 4x that's on the right-hand side, and I want to take it over to the left-hand side. And then I want to take this constant 4 that's here, and I want to take this to the right-hand side. So I'm going to transpose the x variable, but I'm also going to transpose the constant. So on the left-hand side, I already had 5x, right? So I had 5x, and now I'm going to have a minus 4x. Why is it minus 4x? On the right-hand side, it was plus, see? It was plus. So when I transpose it, the sign changes. Now on the right-hand side, I had 6. Right now I'm bringing over a 4 from the left-hand side, but on the left-hand side, it was positive. So when I bring it over, it's going to become negative. 5x minus 4x is just 1x, which is just x. And 6 minus 4 is 2. 6 minus 4 is 2. So again, let's check our answer, okay? So 4 plus 5x is equal to 6 plus 4x. So we have to go to the original problem, okay? So this is 4 plus 5 multiplied by 2, because wherever we see x, we're going to put 2. So this is 5 times 2, okay? And this is going to be 6 plus 4 times 2. We're checking to see if 2 is in fact correct. So this is 4 plus 5 times 2 is 10. And this is 6 plus 4 times 2 is 8. 4 plus 10 is 14. 6 plus 8 is 14. This is mathematically true. 14 is equal to 14. My answer is correct. So what you want to do here, guys, is you want to check your answer every time in the beginning, because you're just learning. Eventually, this is going to come second nature to you, and we'll be able to move a little faster. All right. All right. So here are some practice problems. Excuse me. Here are some practice problems, and to the right of these, you have the answer. Okay, so you want to jot these down, practice them. You want to practice these before you take your quiz. There's a quiz at the end of the chapter. This is how you know what the answer is, but you can also know, even if I didn't give you the answer, by checking your answer, because you know how to check your answer. So you want to make sure you pause this video, write this stuff down, give it a try. And that's it. We've come to the end of this unit. Our next unit is unit 3. And in that unit, we're going to be dealing with multiplication and division. In this unit, we dealt with addition and subtraction. Remember, you have a quiz. You need to get a 70% or higher. All the best. See you in unit 3.